Hello. So yes, this talk is about Node-RED without really being about Node-RED. It's about some of the internals of Node-RED. But let me just introduce everything first. So it is about how we manage multiple NPM modules within a single Git repo. Let me introduce myself. I'm Nick O'Leary. I'm an open source developer at IBM. I created Node-RED about 6 years ago now. I spoke at this meetup 6 years ago exactly, about 2 weeks after we open sourced the original version of Node-RED. So yeah, it's come some way in that time, and I've managed to turn what at the time was a side project in and around my day job. It is now my day job to actually work on this little side project and run the Node-RED project. So yes, I'm open source developer at IBM. I run the project. I'm also on the OpenJS Foundation Cross-Project Council. Yeah, the intonation was wrong there. That was the end of the sentence. The Cross-Project Council. So, very involved with the OpenJS Foundation. If anyone's interested in finding out more about that and stuff going on in that area, do come and grab me as well. So this talk is about Node-RED without being about Node-RED. It's about managing multiple NPM modules in a single repo. Really, it's about how we tore apart the internals of Node-RED and glued it all back together without users knowing. So we did all of this in a maintenance release, effectively, that, yeah, the entire guts were ripped apart and put back together, and no one noticed. Who has heard of Node-RED? A smattering of hands, that's always nice to see. So for all those wondering what it is, so Node-RED it's come from the IoT space about how do you create event-driven applications. So although it's not limited to IoT, any sort of event-driven application, whether it's creating a REST API, integrating systems, or listening for sensor events from a bit of hardware. It came from this idea that we're all seasoned professionals, we can write the code, I can write the code to access a serial port, but the time I spend writing that boilerplate code is time I'm not spent actually solving the problem I'm trying to solve. So it's really trying to get away from having to write code at all. But then with the flexibility that you can write the code when you need to. So it's flow-based programming for event-driven applications. It's a Node.js application. When you run it, you point your web browser at it to get the Node-RED editor, and that's the view you get. The palette down the left-hand side are nodes. Each node represents some sort of functionality, whether it's talking to a serial device, talking to the Twitter API, listening for REST events, or whatever it could be. Each one, well-defined bit of behavior, nicely self-contained, well-defined. And you drag those into the workspace and you draw the wires between them, and they represent the flow of events. So so in this example, the dark blue node up there is actually connected to the IBM IoT platform. When it receives a sensor event, it triggers that top flow. It goes through a node that will transform that JavaScript object, which is what a message is, does some more work, it splits it out. It does stuff, it does interesting stuff. But there's no code written behind those. As the developer, I've just dragged those nodes on, configured them to tell what behaviors I want them to do, and then hit deploy and it's running. So that's Node-RED. But as far as end users are concerned, all they do to get Node-RED installed is they npm install -g Node-RED. And they then have a Node-RED command they can just run and use. And what you actually get in the Node-RED npm module are probably... I spent ages trying to work out how to draw this diagram. I've decided over the 6 years, you get these 3 basic bits. You get the Node.js-based runtime, so that's the thing that's actually running the logic of the flows you create. You get the browser-based editor, but it gets served up by the runtime, so that they are quite tightly coupled. And then you've got the core nodes, those default nodes in the sidebar. I will quickly say, as an open source project, the main way people extend Node-RED is by writing custom nodes for it. At last count, there was about 2,200 third-party nodes available for Node-RED. So there's a huge community of people extending Node-RED, adding nodes, doing interesting stuff. But Node-RED comes with this core set. So when you npm install the Node-RED npm module, that's what you got. And in terms of how that translated to the code, made some efforts to structure the source tree appropriately. There was editor, which was all of the resources for the editor. So the client-side JavaScript, CSS, HTML, images, all of that, all the stuff that has to get served up to the browser. There's the nodes directory, which contains the default palette of nodes. And then there was the red directory, and that was the sort of the entry point to the entire runtime code, and a test directory. So underneath each of those, it was also fairly reasonably well structured and componentized, but we wanted to get to the point where the runtime and the editor were more logically separated, that they weren't embedded in just this one NPM module. So we wanted to tease it out into a number of NPM modules for the internals. And after much head scratching, don't worry about the details, just appreciate the fact the white boxes you can see there are, instead of having the one gray box NPM module, we were going to be breaking it up into these six. I thought there was 7. Which one have I missed? Anyway, a number of internal modules. So you've still got the runtime, you've got the editor component and the core nodes. And the key thing being for the end user, that they would still just npm install the Node-RED module, and it would pull all of these modules in, glue them together, and things will carry on working exactly as they expect. So the question was, how do we restructure the code to now support having multiple npm modules in the one source tree? Or indeed, did we want to split it up into multiple source trees? Very, very, very quickly decided we did not want to start maintaining multiple repositories for all of this stuff. Whole host of reasons for that. Probably the winning reason for me that sold me on day one was a lot of the features we were adding cut across multiple modules. So when we're adding a new feature, it'll have some embodiment in the editor, it'll have some embodiment in the runtime. Some of the core nodes might want to take advantage of it. So trying to coordinate pull requests across multiple repositories to add a feature in was just a headache that felt needless to solve. So we decided to solve a bunch of other headaches instead. So we're keeping it in a single repository. We wanted it to be maintainable, obviously. We didn't want to adopt a whole host of extra tooling. So we didn't want any new developers coming to the project to have to spend a week learning a long list of new commands using tooling that they're not going to be familiar with. So I want to keep it accessible. And also, that's for ourselves as well. We didn't want to have to learn a whole bunch of new tooling for, for the way we were already working. So we did a bit of a trawl, because this is a well-solved problem. I'm not claiming we've broken new ground here. So there was a number of different approaches. The one you stumble across really quickly when you start looking at this is Lerna. Has anyone used Lerna, played with Lerna? A few hands. So Lerna is, like I said, it's the tool you stumble across as soon as you start researching this problem. It gives you a whole suite of tools and command lines you can run to manage multiple NPM modules in one repo. It's used by Babel, WebDriver, Gatsby. There's plenty of big projects using it. So it is battle hardened. And I spent a few days with it just trying to work out how to get started. And yeah, I was put off. It does a lot, and it does a lot of things that we don't need. And that just put me off this idea of having to spend a lot of time working out what we don't need from what it offers to focus on what we do need. Another option some people talk about is Git submodules. A very quick search found this tweet, and that kind of put paid to that. I've used Git submodules before, and I agree with this. You just don't. Again, they're fine. They kind of work. But yeah, the number of times you can screw it up is impressive. So we ended up thinking, well, it must be possible. We're a relatively small code base. Our needs are modest. It can't be that hard. Spoiler alert, it wasn't really. So the rest of the talk is a bit about how have we rolled our own, and what's worked, what hasn't worked, or what else are we going to be doing about it in the future. So to think about, well, what does it mean to have multiple NPM modules in a repository? As a developer, I want to just be able to develop the code and run it, and have the tests run. These are not unreasonable demands. When you've got a source tree like we had, where you've got different components in adjacent directories like this, so directories A and B, in your code, you'll have lots of require statements just requiring the JavaScript files and doing the relative path thing to load it. And that's fine. And that's fine when it's all in one NPM module, because relative paths are fine when you're inside one module. But as soon as you want A and B to be different modules, you can't assume anything about relative locations. What you want to be able to do in module A is just require B. This isn't rocket science. This is all obvious stuff. So the question was, well, how can we arrange our code to manage that? So the trick, and it's not much of a trick, is to put A and B inside a directory called node modules. And then make sure you've got a package.json in each one. So you're starting to build up directories A and B are now directories of what you want your published modules to look like. So when you do require B, node module loading, it works its way up the directory path looking for a directory called node modules. As soon as it finds that, it looks in that directory for the module it's trying to load. Now, most of the time you have node modules because you've run npm install and it's got all your dependencies in, but you can hack that so it actually finds your development code that npm hasn't gone anywhere near. So that's, really, if that's my talk over, really. I mean, that's what we did. We stuck things under node modules. Now, obviously, we didn't want node modules at the top level of the project, because then it would get all cluttered up with all the development dependencies and all the real dependencies that we have to npm install. So we ended up with this structure. So the top level there is a package.json. That one has all of the dependencies in. So all of the dependencies for all of our individual modules are in there, and our development dependencies. And that's the only thing we ever run npm install against. We then have a packages directory just to make sure our fake node modules is not cluttered at the top with the real node modules. And then under that, the source trees for the 7. Actually, it is 7. It's 6 were the white boxes, and the 7th was the big grey. Anyway, of the modules we wanted to end up with. So that now means any code within any of the modules can now just require one of the other modules as if it had been npm installed, and it will just work. But the key thing is, all of our dependencies and development dependencies only are maintained in that top-level package.json. But of course, that raises some challenges and some other things to think about. So here are 5 things. It was 4 things, but then I remembered a 5th. 5 things about what that then meant in terms of how we manage this code. So first about is managing the tests. So the Node-RED code base, we already had this structure that given a source tree, a index.js under A and B, under the test directory we have unit tests, and for every file in the source tree we have a corresponding spec file. And in fact we've got a build task that will fail the build if a file is added to the source tree and we don't add a test file. And after a couple of weeks of that, I added an extra test to make sure we didn't add an empty test file, because it was too easy just to touch the file so it existed to pass the test. So it actually makes sure it's got something in. So we still have some files that just have a stub of a test saying must write some more tests, but the principle's there. Anyway, I digress. That's the test structure we have. So for every source file, we have a spec file for the unit tests. So that means in our test files, they've also got to load the file they're testing. And there's, well, frankly, a lot of relative paths going from the test tree into the source tree. And the fact there was a couple, I think there was about 100 source files in Node-RED with tests. Whenever we did any sort of refactoring and moving files around, that was a lot of work just to get the relative paths all sorted. And that was a real pain. So we found we could actually use the same node module trick. So in the test tree, we added a node module directory and the nr test utils module we added in as a utility that all of the tests could load. And well, we decided because that test module was inherently tied to the state of the Node-RED source tree, it wasn't worth publishing to NPM as its own thing. So it's another little NPM module embedded in the repository used by the tests. And what that does, I mean, that's all of the code that's in there. It knows the relative path from where it is to the source tree. And then it exposes a require and a resolve, as you would recognize from Node's own require and resolve. So now a test can, when it needs to require a particular file or find out its path, it just has to require Node-RED test utils, which because node modules is in the hierarchy of the path, it finds. And then it can use that to require a file in the source tree without having to worry about the relative paths. Now, it was a pain migrating to that because I had to update every single test to use that. But once that's been done, we can now, as and when we move files around, it minimizes the workload to keep things in sync. But doing this was kind of born straight from that idea of putting this node modules into the source hierarchy so that we can add things in that any file can require. Next on the list, obviously, now you've got actual code in node modules that you care about. And the one thing you don't do with node projects is you don't put node modules under version control, so you have node modules in your git ignore. But of course, now we've got, not all node modules are equal, so your git ignore needs to unignore the node modules you actually care about. And that's good because most text editors, VS Code, Atom, whatever you use, will pay attention to git ignore. And by default, they won't list node modules, but if you do that, they will then start showing you the ones you actually want to edit. Then you get to GitHub, and GitHub very helpfully doesn't pay attention to that. And when you commit some changes, it won't generate diffs for files under a directory with node modules in, which is a real pain when you're trying to review changes and all of your source code is in a directory with node modules in. For some reason, if you add the git attributes with that in, it tells GitHub to not do that. Linguist being the module that GitHub uses to identify things about source code. That I forget. That was buried deep in a forum post somewhere, and I was so pleased to find it. Only works for the desktop view. On your mobile view, it still refuses to show the diffs. But that's OK. I don't tend to review source code on my mobile. Managing package versions. So now we've got the top-level package.json, and obviously we've got a package.json inside every module. We wanted to keep the version number of every module in sync. We're not going to do a fixed release of one module. We're going to keep them all in sync for now. So when I said we didn't want lots of new tooling, there's a little bit. So we added a script that I give it a version number, and it will update all the package.jsons to that version, including where we have the dependencies between the different packages. That's nice and easy. There is an issue that as we run NPM outdated and we update our dependency versions, we need to make sure that not only do we update it in the top level, because that's what we're testing against, because that's what we've NPM installed, we need to make sure that percolates down to the individual package.jsons. So here's an example. Our JSON after one, at the top level, I've upgraded it to 165, but the one buried down here is still on 163. So to manage that, we created another one, a verify package dependencies, that basically checks that whatever I say I want at the top level one is reflected in the lower level ones. And that's been added to the build. So again, the build will fail if we forget, when we routinely forget to update the ones. And again, I know Lerna provides all the tooling to do this as well, but these are pretty simple problems to fix. There are a couple gotchas with that. It doesn't check optional dependencies just because I haven't written that code. So we did ship a down-level bcrypt for a couple versions because I updated it at the top level, and because we have it as an optional dependency for reasons, we shipped a couple versions, not spotting we hadn't updated it in the actual module we ship. So that's something to fix. The trickier one is if we add a brand new dependency to the top level, obviously nothing knows which lower level one it ought to be in. So that's still an area prone, we have to keep a close watch on, but we very rarely add new dependencies, so it hasn't been enough of an issue yet. Building a release, we already had a release task that would build our source code and create a directory that we could then run NPM publish in, and a zip file we could stick in the GitHub release. That's now been updated, so now it spits out a TGZ for each of those modules, and we can run NPM publish against each of those tar files. And again, another thing we haven't got, which we should have, is when we do that, it'd be great if it spat out a script that I could run to run those NPM publishes that automatically spots is it a beta release or not, so I get the tags right when I publish it to NPM. So in terms of what we're doing next around this, automating a few more of the chores around dependency checking NPM publishing. But we did this change about a year ago now, and it hasn't got in the way. So really, what we're mainly focused on now is just forgetting about it and just getting on with developing Node-RED. And as far as end users are concerned, they continue just to npm install -g Node-RED. It's worth saying, and I'm sure you'll have the slides at some point to click these links. I don't expect you to memorize them now. A lot of what we did was influenced by Nolan Lawson's post about PouchDB and why they moved away from Lerna, and the LA mono-repo publishing. I mean, everything I've shown you is pretty much the principles are lifted from them. And that's kind of it, really, in terms of what we've done with Node-RED. Like I said, we are carrying on, just getting on with Node-RED. For those familiar with Node-RED, we've talked around getting to our 1.0 release real soon. And September is our goal for getting 1.0 released. You may realize there's about 5 days left in September. So I've got, we're not announcing exactly when, but just keep an eye out in the next few days, because something might get released called 1.0. If you want to try out Node-RED, node-red.org. If you want to talk about any of this stuff, any of Node-RED stuff, any of the OpenJSF stuff, I'm around for a while. So thank you very much.